Hello again, guys. Let's have a look at this congruence question. Again, it's a topic that there doesn't seem to be a clip number for you guys on Haggerty. So let's look at this exam question. But before we do, I wanted to talk to you a bit about congruence. So when you talk about two shapes being congruent, you basically mean that they're equal. They're perfectly identical to each other. All the angles are the same, all the sides are the same. They're absolutely identical. And in GCSE papers, you're usually asked to prove congruency of triangles. I know in your mark scheme, in your revision list, it says something like prove congruency in squares, but I'm kind of hoping, or rectangles, but I'm kind of hoping it's something a little like this. So a question of this type. Hopefully not exactly one of these two. Lol. Because I'm going to be doing another one. So let's talk about congruency. To prove, let's use the magic pen. Okay, so I'm going to say triangle congruency. Okay, so we've got three types of congruency. So in a triangle, you can prove that, in two triangles rather, you can prove that all the sides are the same. So you can prove side, side, side. What this means is, if I've got these two really ugly triangles here, if I can prove that this side is equal to that side, and that side is equal to that side, and that side is equal to that side, I've proven congruency through side, side, side. Right, that's one. The second one is side, angle, side. So if I've got another two really ugly triangles here, and I want to prove side, angle, side, if I can prove this side is equal to that side, and this side is equal to this side, and this is very important, if I can prove the angle between them, so no other angle, the angle between these two sides are equal in the two triangles, then I've proved side, 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 angle, side. And the last one I want to talk about is angle, side, angle. And let's see how that looks. Okay, I've got my triangles. So I've got two angles and the side in between them. So if I can prove this angle is equal to that angle, and that angle is equal to that angle, and the side in between them is equal in both triangles, then I've proved angle, side, angle. Okay, so this is congruency. Now let's apply it and see how this works. This is a 3-mark question, but it's going to be a long clip just because you guys got an introduction to this as well. So let's read the question. ABCD is a rhombus, which it is. Here it is, ABCD. M and N are points on BD such that DN is equal to MB. Unfortunately for you guys, they don't really sort of like label your diagrams anymore. You have to do it yourself. So as soon as you read DN equals to MB, you can do a little DN equals to MB. And there you go. We want to prove that triangle DNC is congruent to triangle BMC. And we can use what they give us in the question. So the first fact we're going to use is that, and I'm going to write up here, DN equals to MB. And this fact is given to us. So I just write given in the bracket. It's a good idea to also keep track of what you've done. So DN and MB are sides. Okay, so let me identify my triangles a bit better. I've got a DNC here and MBC there. Okay, so now if I move my MBC just underneath D and C. And I orient them the right way around, so we're hopefully going to be a little bit more successful. So this is the point M. MB is equal to that one, so that's MB, and the point C is here. Okay, great. Right, so we've proved side. If I look at my shape, it's a rhombus, so I know that all the sides in the rhombus are equal. So DC is a side in the rhombus, so is BC. So I can say DC and BC are equal. So I say DC equals to BC because sides in a rhombus are equal. Okay, so we've got let me label that one here, and that's a side, another side. So because I've got two sides, this angle, side angle, I'm not going to be able to use that one in here. Okay, I've got two sides, so it's one of these two. Now, as tempting as it is to think, oh well, this NC and this MC here, they look reasonably equal, right? So I'm just going to use them and say that they're equal. You can't, because there's no guarantee that they are equal. So I'm not going to be able to use side, side, side. So I'm going to try to use side, angle, side. So let's see how this side, angle, side works. Okay, I've got these two sides here. So I need the angle between them, right? Because we said it only works with the angle between the two sides. So I need these two angles. Okay. Now, it took me a while, but if you look at the big picture, you are going to see that this here, so this DBC, it's an isosceles triangle, okay? Because these two sides are equal. And you notice that B and D are base angles in this isosceles triangle. So they definitely are equal. Okay, so we can use that. So we can say that angle MBC is equal to angle NDC okay, and that happens because base angles, I'm being lazy, but you have to write out the whole thing, yeah? Base angles in isosceles triangles are equal. Okay, so the last important bit in proof, you have to say this is a angle. You have to give a conclusion, which is therefore triangle D and C is congruent to BMC through side angle side. Okay, so this conclusion is very important. Okay, there you go. So this was the first one. I'm gonna do one more on congruency, hopefully up on YouTube in a couple of minutes. So I shall see you soon. Bye.